Okay, so today we'll start talking about Chapter 5, which is all about polynomials. So, when we start a new chapter, and the chapter's titled with the name of some math term, what's usually the first thing we do? We start with a definition and define what we mean by a polynomial. Okay? Alright. So, we're actually going to build up to that definition. There's a bunch of definitions that I want to do before that. That is all going to be kind of related to a polynomial. So this is just going to be a bunch of vocab here to start with. Everybody's okay with that idea? All right. Sure. So we'll start first with the term monomial. So a monomial is just the product of variables and constants. What do I mean by constants? Like a number, right? Like 7 or 12 or the square root of 2 or whatever. So let's look at some examples and try to decide whether these are monomials or not. Sound good? About 2x. Is that a monomial? Yes. Right? It's 2 times x. X is a variable. That works. How about 3x squared y to the 5th? Is that a monomial? Why wouldn't it be? Because of the exponent? Well, isn't x squared, doesn't that just mean x times x? Isn't this just the product of a constant and some variables? Right? It's 3 times x times y times y times y times y. Right? That's still a monomial. That still fits the definition, even though there's an exponent there. About this. That is not. What's wrong with this one? Oh, the negative is fine. Yeah, it's a half of an exponent. What does that mean? That's not a full variable, right? So we can't, that doesn't work. Okay? So what do the exponents need to be? Whole numbers, right? How about this? 3 halves x to the negative 3 y to the 2nd. Is this a monomial? Why not? Nope. That's fine. 3 halves is a constant. That part's okay. Yeah. Yeah, that's the issue there, the negative exponent. 3 over x. Well, that's supposed to be an e. Yeah, whatever the next letter in the alphabet is. It's math class, not English. Is this a monomial? Why do you say that? So it's the product? No, what's going on here? Division is what this is. This is the division of a constant and a variable. That's not our definition. Our definition has to be multiplication. Has to be a product. So no. So the exponents are fine. The 3 is fine. The constant is fine. The exponent on the variable is fine. The problem is we're dividing and not multiplying. How about 3x squared y to the 5th minus 2x to the 5th? What's the issue? Or is this a monomial? Yeah, no, it's not. And the issue is exactly that, is that we're not multiplying everything. We have also some subtraction going on there, right? Oops. It's supposed to be black again. Oops. What about this? Not a monomial. Why not? Yeah. So the square root on the x. The square root on the 5 is fine. The square root on the x is not okay. What do you guys think? Do you think we got a handle on what's monomial and what's not? Yeah? Okay. So the degree of a monomial is going to be the sum of the exponents from the variables. So let's say we have the monomial 5x squared. What's the degree for that guy? 2. Everybody agree with that? Why is the degree 2? The only exponent on the variable is a 2, so the degree is 2. How about 18x to the 3rd, y to the 5th, z to the 10th? The degree is 18. What's the degree on this one? Be careful. The degree is 12. Why doesn't the 2 count? Because it's not on a variable. So The degree of the monomial is only adding up the exponents from the variable parts. Not all the exponents, only the exponents from the variables. Do we feel like we got a handle on the degree of the monomial? Okay. So a polynomial is just going to be a finite sum of monomials. When we use this word finite, what do we mean? It's not infinite, right? We can't have an infinite number of things added all together and still be a polynomial. That's actually going to be a different mathematical term. So let's look at some examples. So we're going to decide whether these are polynomials or not. Sound good? Okay. Is this a polynomial? Yes. Everybody agree with that? Okay. Is this a polynomial? It's not? Why not? Well, what if instead of writing it as minus 7xy, I wrote it as plus negative 7xy? Isn't that the same thing as subtraction? Okay. You want to change your mind now? So we think this is, yes, it is a polynomial, right? Good. This is the point of doing these examples, though, is to show you things that, like, oh, he said sum. What if there's subtraction? Like, does that, isn't, you know, like, because at first you don't think that, right? Like, you need to see the example to be like, oh, yeah, addition or subtraction doesn't really matter there. Yeah, so good. Is that a polynomial? No? Why not? Good. So that guy is not a monomial because it's got division of a variable going on in it. And that's not okay. Is this a polynomial? No. Why not? Where's their division going on? Square root, yeah. It is not, but okay. But you knew it was that symbol was the issue. So I'll take that. No, square roots are not division.
25 or like 5 to the square root of 25, so like you have to divide 25 by like its square root to get to the other square root. I don't know if this is how it is the square root, but it's basically
It's not division, but okay.
No.
It's a square root. That's what it is. Yes. Of course. No, like your explanation of how you found the square root is fine. right?
You have to divide. It's all the square root is always different. Yeah. I think very true.
Everybody feel good about what's a polynomial and what's not a polynomial? Okay. So the degree of a monomial, or I'm sorry, the degree of a polynomial is the largest degree of its monomials. So it's the degree of this polynomial. Yep. Why? Because this monomial has degree 2, this monomial has degree 1, this monomial has degree 0. The biggest degree of the monomials was 2. Everybody happy with that? Okay. What's the degree here? No, not 13. It's 5. So this one has degree 5, this one has degree 5, this one has degree 3. The biggest of those is 5. Everybody okay there? What do you think? We got a handle on this? Right. Yeah. So that's shouldn't be bad. Okay. So the general form for any polynomial in one variable, obviously we've seen polynomials here in the examples that had 2 variables or 3 variables in them. But if we're talking about just a polynomial in one variable, is a subscript n, x to the n, a subscript n minus 1, x to the n minus 1, plus dot dot dot, plus a subscript 1 x, plus a subscript 0. And I'm going to do a little bit of vocab based on this general form. So these A's out front, what do we call these? Those are called coefficients. Those are the numbers in front of our variables, or in this case, single variable. Everybody okay with that idea? Should be vocab we've heard before, right? In fact, we've used coefficient in this class quite a bit already. There are two special coefficients. This first one is called, does anybody remember what this one would be called? It's the leading coefficient. Why is it the leading coefficient? Well, it's on the term with the biggest degree. And this one is a special one. This one is called the constant. Why do you suppose we call it that? Well, there's no variable to it, right? Yeah, no variable. Now, if we look at each one of these pieces, these are called terms. So how many terms would this polynomial have that I've just written? This is actually kind of a tricky question. Well, keep in mind there's a dot, dot, dot in the middle. There's n plus 1 of them. How do I know that? Well, I started with the nth, the n minus 1. The next one would be n minus 2. This one is 1, and then we're at 0. So if I count down from n to 0, how many numbers did I count down from? N plus 1. Count on your fingers, counting down from 5 to 0. 5, 4, 3, 2, 1, 0. 6 things I counted, right? Everybody agree with that? If I count down from n to 0, I counted n plus 1 things, right? Is that okay? That's kind of a tricky question. Okay. So let's look at some polynomials, and we're going to list the following. So we're going to list the leading coefficient, the constant term, the number of terms, and the degree for the polynomial. We're going to do we're going to do quite a few things here. Okay. What's the leading coefficient here? No.
Oh, 7.
No.
And then 8 x 7.
Mm-hmm. That's the leading coefficient, right?
Oh, because you listed from.
Because you have to go from the greatest degree term first. Yeah. We'll keep going and pick up more on this next time.